Type ap.lingerall.com in the address bar and go to the page. Input email and password for login. Please use the registration function for the first time. After registering or logging in, add Jiningzhengji equals true to the address bar and refresh the page. Click on the AI Orthodontic module. Click on the New Plan button to create a new orthodontic plan. Fill in the basic information of the case and confirm it. Enter the case details page and upload the case image data in 1.2 case data. Lateral CPH, frontal smile, oral scanning model are mandatory as the basis for generating an AI solution. Fill a prescription pre-filled if doctors have customized needs. If the doctor chooses auto, the AI algorithm will automatically determine and use the best solution. The plan design page shows the loading status of each part. The entire plan will be fully loaded in less than 20 minutes. This is a fully loaded plan. The entire process is automatically generated by AI. Click View Plan to open the 3D Studio page. Loading the scene may take a few seconds. The system will automatically load all pages, including the final position page, where doctors can immediately view the final treatment results generated by AI. Click to switch among different pages. Pre-processing is the first stage. Doctors can check the effects of model fix and orientation in the pre-processing stage. The model can be adjusted in 3 steps, including attachment removal, model fix, and model orientation. Segmentation is the second stage, allowing doctors to review the results of segmentation and tooth number. Teeth are color-coded, and a button allows viewing the tooth number for each one. If doctors need to adjust the segmentation results, they can follow the system prompts to make the necessary adjustments. Next stage is the initial position. The system provides several tools to help doctors change their view to check the model. Additionally, there are some general tools to view detailed information. Grid provides an orthogonal view, making it easier for doctors to quickly assess approximate dimensions and proportions using the grid. Occlusal contacts present the occlusion through color, with a scale displayed on the right side of the screen. The tooth number button controls whether the tooth numbers are shown on the 3D model. Bolton analysis determines the ratio of the mesiodistal widths of the maxillary teeth to the mandibular teeth, and doctors can click the button to switch the page to a floating window. OB/OJ analysis shows the overbite and overjet status, but when teeth 11 and 41 are missing, this value cannot be calculated. The measuring tool allows doctors add points on the model for 2-point distance or 3-point angle measurement. Their records appear on the left side. Doctors can enter edit mode to adjust the tooth axis and landmarks of the initial position. Click on the target tooth and use the system's movement controls or adjust the tooth axis in the value bar on the right. The landmarks can be adjusted by dragging them on the model. Besides, click Save to upload the modified initial position. Doctors can design a bite jump for the patient in the initial position stage. In bite jumping design mode, doctors can adjust the 6 degrees of freedom of the mandible by dragging the controls on the 3D model or using the value bar on the right. During the bite jumping design process, doctors can also switch to tooth movement mode to fine-tune the positions of certain teeth. Finally, click Save to upload the occlusal jump design. After waiting for the subsequent steps to load, doctors can view the bite jumping design in step 0 on the staging page. Treatment plan is automatically generated by AI based on the uploaded lateral ceph and frontal smile images, which includes 2 nodes, basic treatment plan and treatment expected outcome. There are 2 parts in the basic treatment plan: tooth information and collision resolution. Doctors can adjust and save the form in the basic treatment plan. Then the system will regenerate the expected treatment outcome in subsequent stages. The treatment expected outcome also includes 2 sections: target position reference and midline and occlusion. If the doctor only adjusts and submits the forms in expected outcome of treatment, subsequent stages will be loaded, but the basic treatment plan will not be affected. It should be noted that the expected outcomes are indicative only and may not be achieved due to practical factors. Please refer to the final results as the definitive reference. Next stage is the final position. Doctors can view the model or enter the edit mode to make adjustments to the AI-generated model. The comparison feature allows the final position to be compared with the initial position. Click Edit Final Position to enter the editing mode. The final position can be adjusted in 3 aspects: tooth movement, IPR, and arch curve. Select the tooth and use the movement controls on the 3D model, or adjust the right value bar to move the tooth. The value of each tooth gap on the model represents the IPR, which can be added or modified. Doctors can select anterior or posterior tooth movement in the configuration items on the right side of the screen. Click Arch Curve and drag the control point on the model to adjust the arch curve. To align the teeth with the arch curve, doctors need to enable the option in the configuration settings. Finally, click Save to submit the modified final position. Then the staging stage. AI automatically generates the staging treatment plan based on various medical rules. Doctors can also adjust the original plan by the AI rule preference setting or the manual adjustment. In AI rule preference setting, doctors can cell set and modify AI rules and specify the maximum tooth alignment of one stage. Powerful manual adjustment tools are also available. The movement speed of a single tooth can be adjusted by dragging the corresponding keyframe slider located at the bottom of the screen. Additionally, the tooth position for any keyframe can be modified to adjust the overall trajectory of the tooth. Keyframe controls include options to copy frames, create blank frames, or delete frames, enabling customization of the staging treatment plan based on specific clinical needs. Attachment is automatically generated based on staging plan, which also support doctors to manually add, delete, and edit attachments. In editing mode, attachments or elastics can be dragged and dropped to the desired location on the 3D model. Doctors can also adjust the placement, size, and stage number of each attachment. Additionally, doctors can fine-tune the position of attachments by clicking on the 3D model and using the movement controls. The final stage is aligner, which will only exist if the doctor selects Design Aligner during the information entry, 1.3 project information. Doctors can also adjust the aligner by adding stiffening ribs or modifying its thickness. Doctors can click Submit after confirming the entire plan, and then click the exporting files for printing. Next, click to download the .dsg file. Follow the prompts to transfer the .dsg file into .stl files using the local software, which will generate the dental model and aligner model.